In a world that walks the line, there's a rare few who think outside the box together for the crew. To break the equations, not bound to any rule. Exposing to the world the universe is all view. It takes the talent of the craftsman, it takes the mind of the fool to make the vision realize energy and matter in a duel. To a break, to a duel. The old man Bills was running through his head. Cheryl probably got it hiding under his bed. Penny up the ante, making power for days. Don't listen to a word that the straight dope says. Mike building batteries to power a ship. Victor comes in talking math as the water spiral dip. Sean chucking plasma bolts a mile long. Sheila on the video making tone trumpet prongs. Bernie breaking matter, they said it couldn't be done. And to all the people in the chat, I know you're having fun. So it's time to spend your Saturday with the doping old man Bills.
Hello, everybody, and welcome. My name is Nathan, otherwise known as Old Man Bills. Joe, what's up, man?
Hey, what's up, everybody? Yeah, I was doing the intro hand motions there. Man, explaining this stuff gets intense sometimes. It'd be throwing hands like a drunk guinea on a Sunday, you know?
Yeah, it gets pretty bad, man. It gets worse every time you start doing it too, because then I find it and look for it and just.
That's it, man. That's it.
All right, Joe, is everything magnetism? That's the topic, man. So let me just set it up for you. We watched a little bit of Ashton, and he had someone on from NASA saying that everything was magnetism. So let me just ask you the question: is it?
Like everything else we discussed, that's not such a simple answer. Briefly, no, not everything is magnetism, but everything does have to do with magnetism. And magnetism is a part of it, and it's what I would consider to be a multi-layered function of electromagnetism as a whole. So there's elements of magnetism and polarity that exist at all levels, whether you're talking about the atomic level, all the way up through particles, all the way up through molecules into the macro world, and then way beyond. This is something that we see over and over again is this attractive and repulsive force. And, but again, it's my belief from the very beginning that being that electromagnetism only has manifest effects, so to speak, in the presence of matter, and it really depends on the ratios of energy and matter in a given area that depends on the electromagnetic mode, so to speak, that is present. That magnetism is really only a part of it at that point, based on that logic.
Okay, so does everything hold a charge then?
Yeah. Another loaded question, isn't it? Kind of. Not necessarily hold the charge, but being that everything is in motion and that everything is a disturbance of the still in a cumulative form that exists, there has to be some type of energetic property to even the most inert of matter. And therefore, even at the molecular level, by virtue of that motion, I would say that that motion would, if not a charge, at least a polarity.
Well, can it have charge without the polarity, though?
Can you have charge without the polarity? I mean, well, you could have a separation, but that doesn't, but just because you have a separation of a charge or a separation of a polarity through like a filter, or like how you deal with hot energy and cold energy, and they exist on two sides of the coin, you can have one without the other. But just because you have one doesn't mean that the other doesn't exist. And doesn't exist, and does exist in proportion to the amount that exists of the other side of the coin.
Okay, so
it's an inverse thing, you know. If you have one on this side, it's one on that side.
Does a electret have a charge on it? I mean, that has a pole to it?
Well, it's, I wish I knew more about electrets than I do, because I always feel like I understand them, but at the same time, kind of putting it into words becomes a little bit difficult for me, just because I haven't talked about them enough with people that know. So I could very well stand to be corrected. But does an electret have a charge? I'm going to say it does, and that charge is an accumulation of the um, you know the different composites that exist within an electret itself. So you have a certain structure to the electret with aggregates and other types of materials in there that lead to different interactive oscillations, and those interactive oscillations are charge forming. They're able to actually build a charge based on their etheric impact. I guess that's the way I'll put it. Etheric impact.
Well, we know they have a charge. I guess what I'm asking you is, Joe, does it have a north or south pole? Does it have a dipole? What's in an electric?
So that's a good question. So I I don't know exactly, but what I would presume is that the materials contained within the electret are going to be both positive and negative. Okay, now what they jostle out as far as the static accumulations, I mean, I would suppose that would probably be on the negative energy spectrum of things in a static form until they're broken loose from the electret material itself.
Okay, I ask because if you look at it in some ways, a magnet is simply how do I say this? An amperage field that is stuck exactly where it is, placed at a moment in time. It does not change until it loses the ability to hold the charge. So an electret would be the opposite. So it would be pure electricity holding a charge, right, in a suspended state.
Yeah, I mean, more or less, I mean, an electret would be like an equivalent of a piezoelectric under a continuous pressure strain. So it's always, pulling a voltage out of either its structure or the ether around it, or both. And again, then it's just a matter of being able to discharge and capture that charge for it to become usable for that process to continue again. Because like anything else, it's going to have a maximum amount that it could build up.
So you think a piezoelectric disc would have electric properties, not magnetic?
Well, I mean, it kind of depends. Technically, it could kind of have both, but if you're just talking about a piezo disc into itself, it's probably more similar to an electret than it is, forming any form of magnetism. But at the same token, they don't like the mechanism in which they utilize to work those similar is not the same. Because the piezo depends on a pressure to create the voltage, whereas the electret is kind of on auto run with that same process based on its constituent materials.
So let me just say it this way. An electret, a piezo is more like, and it's just my words, a radiant field than anything that we use. And I'll say it this way. It pushes an electric field really fast, really good, and you see it spike on your oscilloscope. It does push a magnetic field because you're going to be able to pick it up on your speaker, you know what I mean, as it hits. So the sound comes through. So you know that it's going to have both. So here's the thing. When you get to a Tesla coil that oscillates the, oh my God, I can't think of the word right now. It oscillates both fields, right? Why can't I think of that word?
It oscillates both fields, you're saying?
The transverse and longitudinal field.
Oh, okay.
So you get a magnetic and a static field that it oscillates between. The piezo is pulling the same thing. It's oscillating between both of those. I call that new field that it makes a radiant field. So if
Okay.
I say a piezo, I would say it's a radiant field. So then I would look at like anything crystal form that we get it to activate. I would say that that has to be in a radiant form. Being that they're built in radiation is where these things are made and how they're constructed. It would make sense that the lower form of radiation, which would be radiant, would be possible to excite them. So that's where I come off on it. What's your take? Is that good?
Well, I
bad,
mean, I'm actually on board with what you're saying, but just to kind of go that extra degree, we're considering the piezo to be an energy discharge, but you have to remember what it is at its root form. Its root form is a frequency oscillation, and that frequency oscillation is realistically scalar until it's not. So it does collapse, and that's how you end up with the transverse wave out of it, where you get both. But in its regular form, all you're getting is a pure oscillation, which is measurable. And then it becomes analogous to a measurable current.
The reason I ask and the reason I state it that way is because of lab tests. I'll explain the test, and I've explained it many times. To move a static field, you need a radiant field. Okay? To play with the magnetic field inside there, you need a radiant field. When you can do this, you can apply both fields and make plasma.
Okay. Sorry. Before we go further, I want to backtrack slightly because Limited said something important to address before we really move on. So we said that if it's transverse, it's not radiant energy, period. Okay. Now
that's wrong.
I'm gonna
wrong.
I'm gonna play both sides of the field here, where you tend to be right and wrong a little bit, and him too, in my opinion. Okay. It is transverse, okay, until there is an electromagnetic mode discharge. Okay. So until that oscillative energy, the oscillation, the frequency, is measured or used through a conductor as a voltage, it is radiant energy. Okay. It is scalar at that point. Okay. So if you apply pressure to a piece of quartz, okay, and it doesn't discharge a spark, still creating energy, it's still outputting energy, whether it's measurable as a volt or not. Now, this tends to be like an observer effect to a degree, because it's one until it's the other, and it's the act of there being a conductor there, matter in the presence of the radiant field. If you get what I'm putting down here, how I said at the beginning, magnetism is a part of it, blah, 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 right? That's when it makes the change over to a transverse wave. Okay, so it is both.
So hold on. But you have to understand how things are built. I'm putting the magnetic field in, right? So it's transverse, okay? I'm getting the result, okay, which is the effect, which is the longitudinal, right?
Mm-hmm.
But as soon as both are done discharging inside of that, I get an impulse, okay? Goes in, hits here, impulses. The impulse blows out the radiant field, okay? That's what's going on here. So it's technically right that if it's just transverse, it's not radiant. But once you use the transverse field to make a longitudinal field, then the impulse transforms it into a radiant field.
I get what you're saying in the context of where you're putting it. If you're just thinking about just a quartz crystal and that's it, then and nothing else, okay? Then or a piezo disc and nothing else, right? Then it tends to be a little bit different. But in the context that you're saying, I don't disagree.
No, I'm saying that's the way that it works.
Yeah, no, that's definitely the way. The way you're saying is
not just a piezo.
In that context.
It's working the same way in my Tesla coil. Here's the thing. Let me just say this. I know what he's trying to say. Here's the problem with it. He's trying to illustrate the fact that it's got to come out and be a static field out of the number 2 coil. Okay? The problem is it's not. If it was static, the first thing that would happen to you is you'd be the sock in the dryer. You come out and everything clings to your clothes because you're discharging thousands of volts of static electricity into the air, right?
Is that magnetism?
No, it's not.
Does it act like magnetism? I'm just trying to bring up the topic that we're discussing in context of what you're saying.
No, because this is what people aren't understanding. As it goes between one field to the next, it changes the fields together in oscillation. As you resonate both fields together, it changes it. That's the problem. It no longer stays a static field. Matter of fact, you won't have any static value on you whatsoever.
You're right. I mean, I understand that because at that point you've taken an accumulation of static energy, more or less, and you've added flow pattern to it. And now, again, tying it right back into things that we discussed very recently, those flow patterns, and their relationship to matter and such in the vicinity of that flow pattern is going to determine the mode of how it manifests. Once what you're saying with the radiant energy occurs, once the static is put into motion, it's depending on what that flow pattern is as to what you get out. If it's spiralytic, then it's magnetic. So if
see, this is the whole crux of the issue, though. If you can't see that third field is formed, you'll never build the fields around the Earth.
Yeah.
Ever. You'll never understand crystal and energy and stuff like that.
Nope.
It just won't happen. That's the blind spot right there. As soon as you do that and you say static is coming out of it and have zero static value, you've lost everybody, because then, dude, I should be able to stick myself to everything. I should have fuzzy balls running across the room sticking to me. You know what I mean? It doesn't happen that way. It just doesn't. If I touch it, my hair should go way up, right? No, I don't. I get shocked. It doesn't work that way. It's the compression that's changing it too. You are compressing a static field. You're not just discharging it. You're compressing it. You see, you start looking at Wormhurst. Wormhurst is simply shooting it out. It is not compressing in any way possible. It is simply building and discharging, building and discharging. Okay? You go to one of those static electricity machines, right? All it's doing, building and discharging, building and discharging. In this case, you're compressing it. Once you compress it, you've changed that energy. That's the problem. So let me get back to the piezo, and the reason I think it is, and remember I tell you it moves things, right? It's exactly what the piezo is doing. So think about it. You're pulsing in cold energy, something without a high magnetic field. When you do that, it amplifies the electricity in there, because the resonance itself inside the coil is adding a value to it, right? Or it's multiplying the value in it. That's what's happening. So it makes sense, but it does not amplify the magnetic field to it, but slightly, which makes sense if the way you build it. You know what I mean? So that's why I want to say it that way. I 100% believe magnetism is part of everything, but it may be a building block in everything, or it may be the abnormality that we look at and exemplify as the biggest thing, but it doesn't have to be present in every part of it.
Right. Yeah, that's a good point. I mean, I actually learned something interesting that I kind of want to share. I mean, it's somewhat relevant. And I only learned it recently. It was about solvents. And I saw this video on what determines like what's soluble in what, right? And what I never knew, but it made total sense, is it has to do with charge.
Okay.
So if, like, for instance, if you try to get an oil stain out with water or something water-based, it just doesn't work. You'll always have like that oily, greasy residue stain. It doesn't come out of the fabric, etc. Right? But that's because the oil is negatively charged and the water is positively charged.
I didn't know that.
And you need a solvent with a negative charge in order to remove the oil, which is why you would use gasoline or kerosene or rubbing alcohol or naphtha or some kind of dry cleaning agent. I forget what they call that.
Paint thinner for that?
Or something, paint thinner. Sure. Any like, so you have spirit solvents, and then you have water solvents, really, water-based solvents for the most part. And there's others too, but those are the two main ones, right? And it all has to do with charge of what you're trying to remove.
Did not realize they had charge in them.
And I didn't know that up until very recently, but think about it from that magnetic perspective again, right? Opposites attract, but yet when you're talking about a solvent, it's the inverse. The likes attract, they accumulate, they pull it out of the fabric when it's a like charge. And that's the same as it is when you're talking about self-organizing structure, when you're talking about accumulation of different charges. It's the same, just across the board. So these things work on the macroscopic level as well, and it's directly relevant to what you're saying about any sort of static and what ends up happening with the static. It's because it's the accumulation and self-organization of the static energy, so to speak, that allows you to then use other fields, other forces to then redisperse that into something usable. The same with the solvent situation.
Yeah. Dude, I'm blown away. That's pretty cool. Well, hold on. If they have a charge to them, are they like a weak charge? Is that?
I mean, it's a molecular charge. It's the same as ionization, except ionization isn't always just a positive or negative or whatever. I mean, it could be either.
Well, I'm just curious. Like they take a rag and they charge a pipe and it has charge on it. You move a can with it. Can you do the same if you have a solvent like that? That's why I'm asking if it's weak, heavy. What's the level of it? So we can maybe somebody can do a test and they can see it.
Something to think about, something to experiment with. But that also raises the question: is can you get a stain out of fabric, knowing what its solubility is, just by applying an ionic charge to it?
Oh, I don't care. I don't do the laundry.
Well, listen, if you want to solve a dry cleaning problem and become very, very wealthy, maybe you want to think about that one. Then then you can build some Tesla coils. You know what I mean? Like, don't blow off my good ideas, bro.
No more work. How about we go to the other end of it? The off gas that comes off of it, would it be positive or negative based on the charge of the solvent?
I would assume that the vapor of the solvent would probably, mirror that of the original solution.
That's funny, man. Because do gases even hold a charge? I don't deal with gases a lot. So do they hold a charge?
Well, they could certainly be excited, can't they? Right? We see that all the time. You wave around your fluorescent bulb and the thing lights the hell up. I mean, what do you think it's doing in that moment? That's the thing is, a lot of these phenomena that we experience, right, with it, like lighting the fluorescent light bulb, because it's electromagnetic in nature. Okay, there's no solidification of the organizational structure, so to speak, of the energy in those systems, like a crystal, right? So that's to bring it back to the other day. So crystals are permanent, like a magnet, like a neodymium magnet is permanent, right? It just by virtue of being locked into those attributes has the given effect, right? These are all simulated, okay? So when you're dealing with radiant energy, you're creating an unlocked in version of the same. So, once you take away your energy source, then your light goes out. The excitation then over time would dissipate and eventually lose its, I want to say lose its charge, but it would lose its inductive charge that created
Well,
the level of excitement in the first place. Now, whether or not it still had a charge in the first place, I mean, I would assume that everything has some type of polarity bias. That's what I'll call it, a polarity bias.
okay, so this stuff acts like when you have it in your test, right? It acts like it pulled the static out of the coil, right? It took it away, but it also took away the magnetism. So it took that too. But the field is everywhere. Like this stuff it just continues to grow. And the more you compress it, the more it grows. So that's what I'm saying. It feels so different in person than you would think it was. Because you would think, oh my God, you're discharging that. There must be stuff all over the place. No, not really. If there's no discharge coming out, you get like no action, but then the field itself shoots everywhere. Like things start to get hot in the room, all the metal gets hot, and it's everywhere, but it has no static value and it has no magnetic value whatsoever. But I'll say this, if you compress it and then put heat into it, what happens is it takes that entire thing and flips it just like that.
Mhm.
Just instantly, boom, right into a magnetic charge. It'll just boom, right into regular voltage. It takes 1 second to do it or less, and it will flip on you. So that's what I think happens when they apply, like, your feet to the ground down the hall with the socks and things. You're flipping a field. You don't realize it, but that right there, what you're doing is flipping the field. When you drop a magnet off of a high building and they're compressed together with the same pole together, it creates friction in there. And that friction changes and it's flipping a field. So now that flip is what changes the locality that it's going down in to slow it. Because now
Right.
it's reacting with that energy in the radiant field. It can't flip the whole thing. It ain't got enough power. The world is too big. But in that certain spot, it'll flip it. That's why when I tell you a UFO always needs a bubble, it's 100% right, because you have to flip it in the locality that you're in order to do it, because you can't make enough energy to flip it against the world.
Okay, so you're making a couple of good points there. So to kind of boil that down into something, that knowing the components involved, charge, polarity, temperature, rotation, geometry, symmetry, etc. Right? All these different factors that go into these fields, the field geometries. Okay. The key to having it be successful, okay, is to have a separation of the sides of the coin, right? So positive, negative, north, south, hot, cold. You get the point, et cetera, et cetera. Once you have these separations, okay, now you have your yin yang. All right. Now, anytime that you're starting to build an accumulation and under compression of one side of the spectrum over the other, just like anything that is outweighed on one side more than the other, okay, it's going to try and correct itself, okay, because almost everything in the universe is self-correcting in some way, shape, or form. Okay, once you throw something out of equilibrium, it tries to correct itself. All right. So that is the mechanism of the field flip at that point, is because you built up one side heavier than the other, so to speak. So it's got to kind of dump and switch in order
So hold on,
for it to
let me stop you
regain
right
the
there.
equilibrium.
That's propulsion. As soon as it flips and it tries to correct itself, it becomes propulsion. That exact moment. That's why you
Well,
have
right,
to build
because now
it.
and that makes sense, because that introduces a new axis of motion.
Yes. There you go.
Okay, so it would be like a fifth or sixth axis of motion at that point.
Yep.
Which is, again, and I've said all along, It's all upper dimensionally when you start getting the crazier effects. Okay. Those upper dimensional axes, once you start moving those wheels, it starts to, like a gear, pull on the lower dimensional forces by orders of magnitude. Okay. So once you start pulling those upper dimensional axes, which really is dependent on just adding additional axes of movement and rotation, which, it becomes exceedingly hard to kind of fathom what that motion may look like, but it is tangible. And I wish I kind of would have drew it ahead of time. But if you imagine a gyroscope, right? And the gyroscope suspended by like a hook arm that then rotates. But then that hook arm's hooked up to another hook arm that also rotates. And now you have all of these rotating forces. And then you just ignore those arms attached to it, right? And all you do is follow with your head and your eyes the motion of the sphere in the middle. What you're going to notice is that it's a very purposeful motion, repeating pattern, okay, that seems to be all over the place because you have all these different axes that don't make any sense in our traditional way of seeing things, but are omnipresent in the environment that we see.
Sure.
Now, if you could center the ball, so to speak, in this thought experiment that I'm proposing, right? That motion would actually create the effects in themselves, just the motion alone, without any sort of input. Because the more axes that you move, things start to get screwy with how space-time surrounding it is flowing, because it's no longer moving in conjunction with that. It's moving on more axes than it.
Yeah, but motion alone can't do it. You have to have a field to the motion.
I don't know.
Well, okay. I can't take a wagon wheel and get it to spin 7,000 RPM and get it to change something and lift. You know what I mean? I need some kind of force with it. You know what I mean? Because there's force being applied to it. So there has to be something that changes that in order to get this to move.
No,
So I don't
it's just important to remember that anytime you're putting off these fields in general, and you're getting the saturation in a room and it's building layers and all this stuff, those layers are experiencing the exact motions, okay, that I'm describing. It's just not tangible.
No, I agree with the motion, but then you just said right there that those fields. So I'm just trying to say the motion has to have a field of some sort.
Okay.
That was it. That was my only thing. It cannot be by itself. Wood by itself has no field.
Well, I mean, I'll tell you what, if you were to build a massive, probably highly dangerous ride because of the amount of G-forces, right, where you were just in the middle of this gyroscope. Now, they used to have the gyroscopes that used to strap yourself in and then you go around on at least 2 axes, but let's say you jack that up to 6 axes with different spin arms of increasing size, and you were still in the middle of that ball. Okay, I would beg to differ that as the person in this that's centric of that upper dimensional motion, that there wouldn't be some type of objective difference. Like I think that it would.
Oh,
whether or not there's a field.
Yeah, but okay.
I mean, it's speculative. Listen, I don't know. It's just a thought experiment, but
Putting a field has a reaction in any area to be able to create a field based on the field that we live in. Okay, so if you create heat in any way, you're doing it. Rotation and massive speeds can create heat in one way or the other, or it can create cooling in one way or the other. But it's still activating some part of a field to push against you or away from you. So there has to be some form of energy in it. Now, how you transform that energy is on you. Yes, we see Brandon. He's having a good time. So
yeah, we got a lot of good people out in the chat today, as always. Thank you, guys.
Here's the thing. I describe things in a certain way, in a certain pattern, so that everybody gets why things are going to work right when you do them that way. Because right now, I know you're reading, but I'm trying to get a point across. They continue to say everything's magnetism because they're not learning one step comes before the other.
I agree.
They have no idea how to build it. Because they don't know how to build it, we get in the situation where they just regurgitate stupid information. Does that make any sense to you?
I mean, you kind of put me in a hard spot because what you're saying makes sense, but I don't necessarily agree with it at the functional level. Like there's a lot of validity to, especially like the resources at hand that were utilized to make that point in the first place. Like there was a like good amount of validity to it. I think that it's very clickbaity to kind of say everything is magnetism. I mean, I think, and this is something I said to you just before we came on. I really think that if you want to say something is everything, something is actually like if something was everything, like those orbs are everything because um because of how their polarity is and how they organize. And that's something important to realize about charge, right? So if something's negatively charged, that doesn't mean that it only has a negative charge. And I agree with this. Does it make sense? Okay. That just means that it has an offset bias on the interactive perimeter of it that is a negative charge. But there is a positive element to it.
Oh, yeah.
And geometrically, from a three-dimensional perspective, that would be inside of the negative charge. Why? Well, because they have magnetic components of attraction and repulsion and self-organize. And it's that exact geometry that would allow for something to be attracted to and come together, but not so much to smash into each other and blow into oblivion or form a more complex molecule or anything like that. Instead, it's attracted, accumulates, and then locks sort of into place. And then when the next one comes, it falls right into that other place, just like the orbs, did. So I think that everything is more analogous to that, and that is actually a precursor to magnetism. That's my opinion. Is that that's all a precursor to magnetism anyway?
You're making my point for me, Joe.
Yeah. Well, I mean, I'm not here to argue with you. We usually agree.
Yeah, it's not that. It's even in an electric. There's still magnetism in an electric. Okay, there is still an electric field in a magnet. So the problem is if you don't know what two fields are building, you won't realize that that part is in every single field, right? So if you have three elements and you say, okay, the part that we're not considering is the radiant value of any field. A magnet has a radiant field. How do we know? Because it builds out from it. As soon as you spin it really fast, it builds out more, right? It's that field that's building out. You're not building out the magnetism, you're building out the field. In an electric field, in an electric, you're not doing that. It still has a radiant value to it. You see, it's each one you're amplifying in the three. So when I tell you that, it means that there's an A, B, and C field, and you have to put every single one of them in there.
Yeah.
That's why people don't see the radiant field, because they don't put it in the beginning. They're never calculating for it. So then when we get to it, they don't understand it. It defies their laws of everything they wrote down, because very little magnetism, very little static value, but it has the huge, radiant field to it, right?
Yeah.
But then we make a magnet and we say, okay, it's still there. We make an electric, it's still there.
All right.
I mean, that's the problem.
All right. So I was gonna disagree with you, but then you saved that pretty early on for me disagreeing with you, which I'm glad, because I was like, it really can't be radiant with magnetic properties because that just doesn't jive, but it kind of does. Like at the end of the day, remember, it goes back to the episode on scalar that we did and what scalar is. And when you think about the energy flows, it's just like little arrows, okay, on a piece of paper, okay, and your flow pattern, okay, your vector of propagation, so to speak, all right, is deterministic on the type of manifest energy mode that you're going to experience generally. Okay, we fundamentally agreed with that, and whenever whenever we're talking about radiant energies, inward or outward flow, okay, not, in a minimally diffuse state, almost a laminar state, so to speak.
Mhm.
That's not going to be magnetic. Now, there could be elements of that field as it breaks down into turbulence through interference that then have magnetic or excited moments. If the flow of the inward outward vector propagation becomes spiralitic in nature. So if it turns into a vortex at some point in time, that vortex will immediately collapse into a toroidal flow pattern, and that toroidal flow pattern will have magnetic property. Yeah.
Yes, it will.
Mhm.
I've seen that. Well, I think that's what I'm trying to say. There's more than two fields that you're playing with. And I know what Steinmetz said. Okay. And I know he said there's two fields, but I'm telling you, there's a third. And that's one of the problems we're having here. Is they're not accounting for it. When you build something, you have to. It's if you see something in your lab and it comes out as an anomaly, you can't just ignore it.
Mhm.
It's not one of those things you can give a zero value to. I mean,
Yeah.
anything that you have a field for, if you name it a zero, you failed, dude. Just take your physics diploma and go wipe your butt with it and throw it away. Because
Amen.
that's about what it's worth.
Well,
Because
that's what John Bigman was just saying in the chat too. He was saying, yeah, but Joe, no matter how hard you try, you're always going to have a magnetic component to it. It's part of the backflow. So that's actually perfect. I agree, and that's case in point. Is that it's in that case it's a mechanism of the backflow, which then makes it a secondary component, not a primary component. So
yes,
when you're talking about but for, okay, that is but for that backflow that then collapses into toroidal magnetic properties
oh
from
man,
you know so it's a component of, but is not, it's not a building block, it's a result. That's the point. So it's sort of like saying, I built a skyscraper out of Legos, so all Legos are skyscrapers. No, not all Legos are skyscrapers, but you could use Legos to build a
yes.
skyscraper. that's that's sort of what it is, right? Um, and and that's why it can't be everything, is because it is a manifest byproduct.
No, no.
It is a secondary or tertiary function.
So you would have to have two functions together to make it, or three to make that field. Is that what you're saying?
Right. I mean, it's like you experienced when you were dealing with the spacing on primary coils, where you would have arcing, then you would have a plasmatic discharge, and then you would have a magnetic discharge, and then if you got it perfectly arranged, magnetic field would suck in on its side, and that's when you have the highest power input. It's because the magnetism is still there, but the toroidal flow pattern has become so tight that it becomes longitudinal in a way. So in that case, it becomes confusing because it's on so many levels. And I mean that. It's like, like toroids just inherently exist, and toroidal flow patterns are inherently magnetic in their nature. And how they manifest in their magnetic properties is largely deterministic. If they're traditionally polar, or if they're like, I don't want to say monopole because it's not, but you get what I'm saying. Like where it has a charge bias in one direction or the other, like I described before.
Yes. Well, you see, this is why I do the experiments in forward and then in reverse, right? if I can use a Tesla coil to turn on a light bulb, right? Can I use that same energy I'd use to turn on a light bulb to turn on a Tesla coil? And the answer is yes. See, that's the thing. If you do them back and forth, you could find out what the fields are actually doing. That's
Yep.
a lot of people don't do that. They just do the one, hey, it worked, it was great, it's outstanding, but I don't like it that way. I want to know what it's actually doing, how you're making it, what parts are there,
Right.
and things like that. So, you know, it's kind of hard because now when you get to matter, was there magnetism to build the matter? See, because I think there was, but then matter itself displays no magnetic properties. But then in some instances, it can. So
Yeah, and this is where it like, and I think like this is where like particle science kind of, you know, if it proved anything, it kind of proves this. When you go up in scale and down in scale, it's just omnipresent, fractal and repeating. So when you say, well, and then there's no magnetic field in this, right? If you go down to the constituents of the oscillatory effects or static charge or whatever it is, okay, that is making up that field, okay, at that point in time, those themselves are magnetic in their ideology. See what I mean? So, no, macroscopically, no effect. When you break it down to the pieces, every single piece of it has a magnetic function. But then you go into them, and then they don't have a magnetic function until they do again. You just keep on zooming in and in and in, and it's just you could lose your hair trying to think about it because it just goes like that. That's how it goes.
So here's the thing that gets me. What happens if you, through a coil, put light in and it creates mass?
Run that by me one more time. I'm sorry.
If you took a coil that was strong enough and you put light through it and it created mass, okay, hypothetical, right? What then? Because you know that there's magnetism in the light. No matter what you do, magnetism had to be part of it to create the light. Then it goes through and it creates mass, but you say mass has no magnetic value, right? But then
I didn't say that, but okay.
Well, we're in the hypothetical. So then you go, okay. Now it comes to a fundamental question. Did you lose it or did you just drop it down to a microscopic scale? That's kind of the thing here.
Right.
So that's why they talk about states of matter and things like that. So it's kind of odd, but a rock in itself probably has everything in there. And we don't realize it because the amount of it has to be so minuscule in order to have just mass by itself. Or not by itself, but you know what I mean? The majority of it, the 99% or however you want to say it.
Right. Yeah, it's a lot to think about, man. I don't know that I have it off the. I mean, it's somewhat rhetorical, but I don't really have a response to that. You know, you can make mass out of light, though. It's been known for a very long time that if you slam it with enough gamma, it'll start to accumulate mass. So you can make matter out of light. Now, I mean, if your coil's powerful enough to be emitting, high power gamma radiation, and you put some coherent light source in, you probably start to get some good accumulation, I would assume. But it probably doesn't even have to be that strong if all the resonance values are in check. And that's where it comes in, because the amplification at that point, in my opinion, would happen at the microscopic level. Okay, so you would have these intense reactions on a very, very, very small level that would really probably lead to kind of like Bernie does, like a monoatomic discharge accumulation. But it all has to do with resonance at that point. And, the light would have, the wavelengths of the light would have to be, properly in tune with everything else that's going on in your field. That's proper densities.
We have examples of lightning hitting rocks. And when they do, and you keep that rock in the same place. So like you hit a boulder with it. And they have ancient time stories, and we can go out to see them today. You could go over to the rock and hit it. And it rings like a bell. It pings. Ping, ping. Just like that, right? You go over to the rock next to it and hit it with your hammer, right? Thud, Dud, dud. So what happened is all the electricity went through it, okay? The light went through it, and it rearranged the molecules inside that rock, okay? So that it has to be connected in that vortex line that it created in that rock, okay? In order to change the value of the sound. Now, if you move the rock from where it sits, it will no longer make that pinging sound. It no longer has the same value because it's drilled into not just that, but all the way down to the next rock. So, in order to do that, you must have a magnetic value inside that rock. You must have an electrical value inside that rock. You get what I'm saying to you?
Well, right. I mean, you're gonna find values wherever you look for them if you go close enough in. That's that's what the spectrum is made of. Like our entire reality spectrum is made of just all variations of these different electromagnetic interferences, basically in different states of compression. While you were saying that, I literally hallucinated something that like kind of made me go, "Oh no!" And I like whether or not I want to mention this, I don't really know. But if you take your coil, okay, and then put your two plates together, and you get your laser, and then you reflect that laser back through where it came.
I don't know if I like this at all. Go ahead.
I'm pretty sure that's your matter beam.
Plasmoid?
That's your matter? No, that's your matter beam, man. That's your phaser. Because you have full resonant coherence and then inversing onto itself, recharging and then so it's basically creating a laser, then creating matter out of the high coherent light that's in full-blown resonance with the system because it was created thereof, and then recharges and creates matter and then blasts off with it. I'm pretty sure that's how that might work.
Okay. Oh my God. So, all right, we're not hallucinating. Okay, I got one for you then. What if it's literally this? It has to form this. It has to cross. It can't go like this, okay? Not two dudes, where it has to cross, okay? And I'll say it like this, because as soon as you go like this and cross it in some way, they spin. And as soon as they spin, they can accumulate more. And the more energy accumulates in that ball, then it can create the matter. So it has to cross in some way or have a...
That's if you want to keep the matter. If you wanted to blast the matter off into something using wild amounts of kinetic energy, well, then you don't want that rotational force in that case as much. You want to be able to produce it, blast it in, have it do its thing as it's doing the pass through, and then out it goes.
Well, see, okay. Sometimes you want two different fields that look like they're the same field. You need one that shows the laser, okay, that shows the light, but the second field you don't want seen at all. You want that to just go over there and change something on molecular level as soon as it hits it, right? But you need the two hitting together in order to make the result. So sometimes you want different. And then if you put them together, you can get pressure. And in those pressures, it'll come out just like we talked about with the piezo. Boom, 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 boom. That's what that coil inside of a coil inside of a coil, that was part of what that experiment was.
Well, and right in line with that would be, and what's the best way to say this? The star in a jar, right?
Okay.
And then what Merkaba was trying to do. But technically speaking, if you get your toroidal patterns and your null zone correct, and you have it where you have a secondary toroidal flow inside that actually gains energy through the eddy currents, that would be I wish I could draw it. Think of a toroid inside of a toroid, and then the flow patterns and the torsion that would occur in the internal structure of the second torus, the internal torus. right? You'd have the same exact null zone, but you would have all these eddy currents that stir up additional torsion and energy, creating a higher density shield, so to speak, around it. And if you could technically get light into that situation and everything's in pure resonance, it would act as a simulated star in a jar. It would have a sustained atmospheric cavitation effect that would occur, because you would have hemispherical and polar toroidal flow motions times 2 that would then allow for that sort of compression to potentially take place. Once you have light caught up into that high energy field, provided that it's still taking in atmospheric energy, and because at that point, if you've gotten to this point, you've broken locality, by the way. So now you have to still concern yourself with how much atmosphere is coming in. Now you have atmosphere coming in, and that could also lead to matter accumulation as well under that particular circumstance. Which is the same thing as you've been saying about the layer, same sort of deal. But I think that's one thing we've never really touched on is the the intertoroidal the intertoroidal torsion and eddy currents that actually churn up and amplify. So I think that that's something that we haven't really said, but is definitely present.
So check this out, Joe. I'm going to say this, and I just need you to understand it the way that it heads in my mind, right?
Yep.
Okay. I'm taking my original field. I'm taking my transverse and my longitudinal field and my Tesla coil, and I'm creating my radiant energy for a reason. Now I know I need to push that in order to get force, right? So I know I'm creating this, right? But I'm creating it in order to speak to the field that's already going around us, right? Now I want to get that mixed in and heavily mixed with the atmosphere itself, right? But now I want to flip it and then pulse it as fast as I possibly can. So now
Okay.
I need some sort of magnetic field to interact with that, right? At the point where it exits out of that tube. Okay. Say if I did my original one, then I have another one around it. I need that point to flip, and then I need that piezo to hit it. Okay. Because I want to create propulsion out of it.
Yeah. Well, I mean, that makes total sense, because that's just like, if you're laying in the bed with Mrs. and you stay inside and you roll her over, and as soon as she flips, you give her a good pump, she's gonna hit the fucking headboard. I would say that is definitely recipe for propulsion.
Wow.
Just saying. It is all the same after all.
Well, what I'm trying to do is identify it so that people understand why you have to put everything in process, because you wouldn't know how to flip the field. You would think that a very tiny, small field is a radiant field like this. You'd be going, I got a radiant field. It's like this when the fucking thing's out the whole goddamn room. Okay. Mm-hmm. By the way, that lady probably blast some gas on you, man, and blow you away. Okay, keep you off of her. You know what?
No, listen, there wouldn't be a second time if that's what she's gonna do.
Dude, all right.
You have to plug it up. We sell solutions for this. Coming soon to the Old Man Build store near you. Cure all of her imbalances and her flatulence during.
Get your organite butt plug here.
Now with a hush gasket.
Hush gasket. Oh my God. Give her a pressure release tube. Oh, that's terrible, Joe.
Like one of those, like a keg, when you're fermenting something, it's like a bubbler, and you see the bubble come up through the water.
It's up to a Bunsen burner.
That's terrible.
Oh my God. All right, Joe, since we're already off the rails, you know what? I didn't think we would get to the part where we did so fast, where we knew that everything was magnetism, because I was going to play the game. Okay. So let me just show it. We'll go ahead and play it anyway.
All right, let's do it.
All right. So old man Bill's ideas about magnetism.
What is this? Oh my God. All right, let's go. I'm down.
Okay. All right. Is steel magnetic? Okay, hold on. I clicked the wrong one. There we go. You see it? Yeah, okay. So piece of steel. Is it magnetic?
Steel, yeah.
Okay. A pretty simple one, right?
I mean, you know, some more than other, but yeah.
How about brass?
Somewhat.
How about plastic?
It depends. I've seen the experiments. Depends. Generally not, but depends.
Okay. How about a chicken?
Well, I mean, women always seem to be attracted to my cock, so probably.
Okay, hold on.
Just making joke. I mean,
if the chicken has iron in its blood, it'd probably be magnetic, wouldn't it?
I would say so.
How about the earth? Is it magnetic?
Yeah.
How about the sun?
Sure.
All right. See if we got one to stump you here. How about the egg guy that we saw?
No, it's just an asshole.
He's repulsive.
Get that thing off the screen. It's like Bob Grant back in the day. Get off my phone. You remember that guy? See, I told you I'm old, man. Yeah.
All right, man. How about poo? Is poo magnetic?
It depends on what I ate.
Swallowing quarters? Oh, man. Oh, how about a bottle of mushrooms, man?
I don't know. No. No, I don't know.
All I know is I must have had some of these before I started, dude, because this is just bad.
Yeah, this is rough, man. I love it though. Let's keep going.
That was it. Yeah, that's all
Oh
I
no,
had.
listen, that was plenty.
Oh man. Well, no, because like everything has magnetism. Had we not come up with that earlier, it would have been better. Now it just kind of sucks because we already knew the poo had magnetism based on what you ate, based on what how much iron's in your blood. Oh
yeah.
man. Oh, that's terrible. Yeah, you can make your organite plug magnetic. It's all in layering. If you needed a quick release to pull it out and you had a magnet on your headboard, I guess you could make it work.
Yeah.
Oh man.
Oh boy. You really get me sometimes, Nathan. I gotta say. It's terrible. I have a filthy sense of humor.
Oh.
Sinner. Not me, brother. That's all you.
Oh my god. That'd be hot sellers.
I'll stick to my rose quartz and whatever else the Asians do, right?
They just shove them in there raw, man.
Yeah.
They polish them up and there you go. That's each on agrees. Oh my god. Now that we're all off track. No. So bad, dude. Never a show goes by where we don't go off track.
Yeah, listen, this is the only place that you get it all. Okay, you get to have a ridiculously boring physics discussion made not so boring because we speak like we're a couple of guys drinking beers in somebody's shed, and with a bad sense of humor, and it's just all encompassing. So welcome. That's it. Like if everybody else, like they come on, it's also serious. And like, listen, we know when to be serious too. I mean, we can't usually keep it together for that long, but you know, I watch these shows and I'm like, oh my God, what a snooze fest. Jesus.
You get about an hour. That's about it. That's what you get. Oh man. Yeah, but dude, they got all this stuff out there. So I guess in the question, if everything is magnetism, in small parts, everything I guess is. I mean, you can make a real legitimate argument that everything has it in it, but is it all like magnetism, like they would say it and state in one of those questions? No. Like,
It's rough, man. It's chicken or the egg, because yes, is it more or less omnipresent at different scales? Absolutely.
Yeah.
Is it the smallest piece? The answer to that for me is always going to be no. But at the same exact time, what does it really matter? It's just an ever-present attribute of things that we, that find in our reality, really.
I think energy is far different than what we think it is. It's just none of the definitions really cover what energy really is. They cover parts of energy, what it can be transformed into and stuff like that, but they don't cover what it really is. They don't have a word for it that I know of, unless you say ether. Then you say, okay, well, then that's pretty much everything, right? Everything that has a value that moves, motion, electric, anything like that is all ether. So all
Correct.
of that is energy.
It's all right. That's where I'm going to agree 100% is that it's potential, and then it falls out of potential into some form of manifestation via disturbance. That's it. Like, that's sort of what it boils down to. I mean, one thing I've been fighting myself on lately too is light, because the more I think about it, the less I kind of want to concede to the idea that when you look up at the sky, that's 20 million years ago at the surface of that star, that's the light that's being absorbed. I don't know how much I buy that anymore. The more and more I think about it, I'm starting to really think about it like the chain tied up to the back of the pickup truck. Sort of how I'm seeing it. But
well, explain a little more since you brought us into this.
Well, yeah, I mean, just in general, I mean, I think that if everything's a shove of the ether, right, just like anything that's full. So if you have an area full of potential, okay, it's full of potential, it's non-manifest. And if you sit there and you push, right, you just push. Now, everything in that direction and everything surrounding it is affected by that push. So if light is just a disturbance of the ether, which I believe it is, okay, that disturbance is pushing the ether in front of it, which then would have quantum effect in terms of, its manifestation at another location. Because once you disturb the pushing force of the ether, it pushes everything in front of it too, which means that it would not necessarily have a quantifiable speed. It would be immediately transmitted, so to speak. Now, obviously, there's a lot of that. There are variables here. There's any sort of matter in the way, other energy fields, et cetera, et cetera. But at the end of the day, if you're just talking about pure potential and you push that pure potential, the instant it moves at all, it just moved over there. And where it moved over there, it fell into a degree of dispersal. Because it was laminar in nature until it became diffuse. It would only become diffuse upon being disrupted.
Okay, so it's like a big chunk of ice on a lake. As soon as you go to one side of the lake and push the ice, the other side of the lake, it pushes against the shore.
Right. Or if you tie a chain to a pickup truck, and the chain's a mile long, and you have somebody holding on to the end, if the pickup truck moves 1 inch, the person that's holding onto the chain is dragged 1 inch. Obviously,
Right.
there's variables in that. There's stretch, blah blah blah. Like, listen, perfect world, perfect scenario. That's what you'd say, right? And that's sort of what I'm saying. And if it was 100 miles long, it would be the same thing. You pulled the chain 1 inch at that point, so it would move 1 inch. So whatever's attached to that chain at the end would move 1 inch.
So let me ask you this. Is there any value that takes away from it when you cross magnetic fields? So as you come in from whatever star you're at and you go into the solar system, every planet that's there, is there a value that take away every time a planet comes near that beam of light that's supposed to be coming at you? You know what I mean? For every sun, every planet, thing like that? Or is it when you tapped it on one side, you immediately got the value of everything receiving it?
I mean, that's. I'm thinking about this for 1 second. I'm just
Yeah,
tying
go
it into my
ahead.
own analogy to kind of. Well, no, because okay, so we know that there's this. Okay, this is a complicated question. Okay,
Oh, I
because
know it is. You brought up
right,
light.
right. I mean, this is also the most like I'm like this is a complicated question. We're discussing the most complicated unknown science that the best physicists in the world have not figured out. So yes, this is a hard question. But if we're to stay true to what I'm saying, and there's a degree of luminosity that occurs in the, we'll call it photonic propagation waveform, okay, of light, emitted light through the ether, and its etheric push. The observer at that point, which would collapse the waveform into particle, right, would be at the point of first interference. At the point of first interference, you'd have a collapse that occurs, but as soon as it passes by, the rest would disturb the initial emission because of the same exact logic that occurs when any luminosity reaches a point of differential interference. It would create turbulence, and that turbulence would actually deteriorate some, or in some cases all, of that light signal. But that's what we would define as a shadow at that point, right? But you could still have a diffuse, but once it collapses into a non-coherent and non-laminar state of its emission, okay, then it's subject to becoming diffuse. Okay, and through that diffusion, you would have a dispersal of that energy over a much greater area, which would then act to probably knock down a significant amount of the energy and directionality of the original vector. Again, wildly complicated question, off the cuff response, best I could really do.
So I would agree with you that it would be the same value once it gets out of the original solar system it was created in. And I say that because if you think of the solar system has a bubble around it, right? It would first have to interact with that, and that would lessen the value, and then it goes, right? But then again, interaction between anything lining up with it would be like a solar eclipse or something like that, right? So that it would change the light. It would change the value of it, and you wouldn't see the star either way, right? Because when they line up, you don't see them. So I always worry about different lenses, and we don't usually talk about them, but they appear every time that you start putting magnetic fields and electric fields all together, you start to get a lens effect. So if there's a bubble around every solar system, then there's a lens effect around every solar system. Things become bigger or smaller based on that lens effect. They also take away the energy you add to it. So that's kind of what's going on here. But light itself is pretty easy to create. Anytime you take a high voltage field with a very low magnetic field and you put them together, you're going to make light. The more magnetics to put into it, the different colors that come out of it. And it's
Yep.
just a scaling. So
Right.
it goes back to the conversion of field around a planet. A planet has a very low magnetic field.
Well, hold on.
However,
Pause right there, because I'm going to lose this. Okay. What you just said about the refraction, the prismatic refraction, breaking apart light into the rainbow of spectrum of colors,
mhm.
that is proof that it's etheric push. By the way, in my opinion, that is proof that it's etheric push, because it could be one or all depending on how it's refracted, and it's undetermined until that refraction occurs. To break it into the spectrum, the broadband spectrum, and the only thing that could have all in one is something that is only strictly potential, because it is potentially everything or potentially one thing or another, right? Or everything. But it's undetermined until it is refracted. So that is, in my opinion, the proof of light being an etheric push. That's it. Like, it's, to me, it makes total sense. It's probably way more complicated. I could see it in my head, but like, that's not words. So
So, so let me ask you. They keep saying light's a wave, light's a particle. You know what I mean? You're saying it's etheric push, right?
okay. So light's a wave. So what's its frequency?
Well,
What's white light, which contains all other potentials? What's its frequency?
hang on.
Because the answer to that is so complicated, because it really couldn't, because it would have to be divisible, by every single other wavelength. It would have to be a number that is divisible by every single other wavelength fractionally in order for it to create a full spectrum of light.
I disagree.
How so?
And just in this way, so you tell me if I'm on the right or wrong level here. High voltage has no light until it interacts with something.
Well, yeah, I mean, we could agree about that. Sure.
Okay. So, but when it does have a frequency to it. You see, because you have to have your frequency up and your amperage low, that means that you're still getting your frequency through it in your pattern, right? And it's still hitting it. And then when it does hit it and creates a plasma, every band of that plasma has frequency in it.
So let me ask you, right? So every band of the plasma has frequency in it, but that's after manifest. If it's etheric push, okay, and all it is a push of potential, then it's nothing until it interacts. Which means that if you try to measure what its frequency is, you can't, because at time of measure you've interacted with it.
So you're differentiating. There's no light in the darkness until it interacts with the planet, where most people think there's light all the way to the planet.
Correct. And from point A to point B, okay, is really just a matter of, if I move my hand an inch here, anything in that direction of something that could potentially observe it, that push has already occurred.
So hold on, it
It
builds
doesn't need
out.
to transverse the fucking universe. you know what I mean? It doesn't need to do that. Like, it pushed, and if it has the potential to be observed in a direct line of sight by an observer, then at that point, like, that's what you receive, that information.
Okay, hold on. So it's building out just like a scalar would. Scalar would build out around an object and then be nothing, absolutely nothing, until another object comes up, another sphere is put there, then it would pull in that same energy right there as scalar, right? And then it would activate the second object.
Damn,
That's
Skippy.
exactly the way it works.
Damn,
Boom,
Skippy.
boom.
Like, or more simply, like you said, there is no light in the darkness. When you look up at the sky, in between you and the light emission that you're seeing as a star, let's say, in between point A and point B, there is no light.
Mhm.
It
So
is
that's
it is like every other form of electromagnetism where it doesn't matter until it matters, right? It doesn't matter until it actually interacts with matter. If not for matter, then none of the electromagnetic effects exist. Light sheds none because it's a push to nothing. So there you go. And you know, like I had that profound realization one time, and honestly, it like actually kind of put me into like some kind of crisis, like trying to get my head around it. But there came a point a few years ago where like I realized there was one light in a room, and the room was mostly kind of dark, but like I could see where the light was shining. And then I realized something. There is no light in this entire room. I'm in a room of darkness, and the only things that are illuminated has nothing to do with the room itself. It has everything to do with where the light is reflecting off. And that was it. That was it. Like that's when I realized I was like, this room is completely dark between point A and point B.
hmm
It's lighting the walls and the floor.
That's so interesting. So let's get back to it. Is light a particle? Is it a wave? So we know that there's an interaction that happens first, but in that, after that interaction, right, or while it's happening, does it now shoot down to the planet as a wave, or is it still in that scalar state where it's now everywhere? Because we see blue, you know, when we look up, and it seems like it's all around us, but it's not on us, or light spectrum of something based on the, oh my God, based on the mirror effect. As soon as it touches something, then the light changes the color, right? So as it hits it, boom, it brings down blue, but it turns out yellow because of how it reacts to it. Is that right? It's got to be something like that because it's there's got to be a reflection in it or a value to what it hits that gives it the color.
Well, what gives it the color is what it's reflecting. So, and this goes back to my, yeah, I always refer back to when we used to talk about it, but it's so long ago, I might as well just say it as if it's new again. But
Mhm.
um, everything that you observe is actually inverse of the truth of what it is. So everything that it's taking in, utilizing, and absorbing of itself, okay, is not what you're seeing. You're just seeing actually what's being pushed off, right? So that's the deterministic factor of color and its interaction with matter. Um, because at that point it's taking all of the etheric push potential, so to speak, if you want to consider it that, and some of it it's you know it's creating coherency and then shoving some of it back depending on you know its makeup. um and that's actually one of the reasons why I was so interested, and I forget the name of the gentleman that you had showed the pictures of, but he was doing some kind of plasma experiment where he was actually splitting the plasma apart and then it was creating like a rainbow spectrum of it. I forget what that was,
I
but I was like,
remember, yeah.
yeah, I don't remember the guy's name, but you showed it. And I was like, wow, that's crazy. I was like, do you understand how significant this is that he's breaking the plasma into a color spectrum? Because that's speaking the volumes of the frequency. Because just like every note is a different frequency, and every you know like every color is a different frequency too. Um, and yeah, I think Mike Merrick said it before and whatnot. Is it? Yeah, light is definitely a wave form. That is the etheric push, right? It's a waveform. Does it act like a particle in practical use once the interaction has occurred? Well, I mean, that's been the model. Like that's been the quantum model, and I don't necessarily disagree with that because there's attributes that it shows once the interactions take place that does have it act like a particle as well. But you know, again, is that what it really is? No, it's only what it is after it interacts.
It's interesting.
Yeah, it's quantum physics.
Yeah.
I might not buy all of it, but some of it's pretty good. Some of it's pretty good.
No, because I can see the wave itself, right? When you put out the plasma and stuff like that, so you see the wave, you know the wave's there, and you're able to see it with the different lights that it puts out. Okay, that's
Mhm.
pretty simple. But when it comes into the earth, we're looking at it as it's everywhere, all at once. It's like a providing source until everything reflects back to it. So is it the things that's reflecting back to it putting off the wave? It's that interaction that's got to be putting off the wave of the color, not
Oh,
necessarily the source.
absolutely, it's absolutely the interaction. Absolutely, it has nothing to do with the light itself. It's not unless if you modulate the light, which is a form of interaction, that it wouldn't be as a result of the matter interaction as opposed to the light itself. The light itself is just, again, it's just a potential is all it is. And just like any potential, or pressure wave in the potential, or however you want to think about it, like not all waves at the beach are the same, right? Like if you've ever gone out like boogie boarding or surfing or something like that, you know that you go out into the ocean and you're sitting there and you're paddling around with the rollers, and then one that you almost kind of catch, and it's going to be a few minutes before that proper big wave comes in, the one where it's big and you could hook and ride in on it, right? So not all etheric pushes, so to speak, are equal in terms of what they are as they, we want to call it transverse, but it's not really, whatever, from point A to point B, okay? Not all of them are equal in that regard, but they're all equal in the fact that the potential could be split up in the same way. That's why white light is white light, and it'll always react that same exact way. I kind of lost some of the comments, but I just want to throw out limited in the comments. I agree with most of what he's actually saying. He's making a lot of good points, but I kind of lost them. But
I'll put it up for you.
yeah, well, it was a little bit ago, let's say.
Proving the making of hydrogen, all the elements can be made from
Yep.
hydrogen alone. Yeah,
Yep,
true.
that one was a good one, and that ties directly back into conversations we had before about plasma and hydrogen and their relationship, because plasma and hydrogen are, in my opinion, two sides of the same coin. Okay, you have plasma, which is matter like energy, and then you have hydrogen, which is energy like matter. Okay,
Okay.
they both ride that line right in the center, and plasma will always, like, hydrogen will gladly turn into plasma and be returned to a more pure form of energy state, and plasma could return to an energy only state. Plasma could also, as we well know through some of these transmutive processes that we've discussed, plasma could also manifest in the form of hydrogen. Hydrogen is the constituent element of all other elements. Period. End of story. Hard stop. It's the constituent of all other matter. It is the prima materia of elemental, of elements in general. And under the proper conditions, it's my belief that you could turn hydrogen into anything you want.
Isn't that listed on Russell's scale as the first thing?
Dude, you know that I come up with all my own stuff, and that, yeah, I read and I watch and this and that, but like, I don't know anybody's work. I'm just literally a guy that like meditated myself into like some forms of conversation that, like, I don't even understand how I understand.
we
it's just it.
Oh, never mind then.
I don't know. Yeah, probably. If you said so, I believe you. You're one of my best friends, buddy, and I trust you.
Well, they name it at the top, and then it goes into the S all the way down. And yeah, everything else gains an electron or a proton from it, and then it's created, right? So it's one electron, one proton.
Well, right. It's got a valence electron. So that's the precursor to everything,
Yeah.
having a single valence electron.
Oh man. So hold on a minute. Dennis said that he had a breakout from the rod down the center, and which means he'd run at least 40 volts through that thing or run AC through it. I'm kind of curious to see if he had it on his page or not. Dennis, if you don't mind, let us know because I'd love to see it. So I have no doubt that he flipped that field as soon as he brought the voltage up. Because usually the cold energy, we run it at 10 volts, you know what I mean, 15, 20 volts sometimes. As soon as you get beyond that, you might as well have connected the number 2 coil to it because it's going to start discharging. So that's why when I do the energy and I put a bigger pipe in there, it immediately turns the energy from being able to oscillate so fast and make us, what would be known as a static field. It brings it back down to a magnetic field. And it starts creating more magnetism in it because it cannot oscillate and discharge that fast because you're creating too much impedance for it. Even though it's on the inside of the coil and it's not attached to anything, it's still creating impedance because it's part of the mass of the coil because the frequency says it is. And the frequency is just the time it takes to discharge, right? So if you interrupt that frequency by putting it down there, you're interrupting the time for discharge. So it now takes longer. So now you're accumulating the magnetic field inside of there. Instead of shooting it out fast, it shoots it out slow. You get a higher discharge.
Good point. Yep, build capacitance that way, and yeah. We're a little over halfway, I would assume. I just want to take a minute to, if I can, to thank everybody who's donated to my fundraiser for the mining. I really do. Wildly generous. I'm so humbled and thankful for everybody that's contributed, and still working toward the goal and everything. There's actually enough money for me to go and dig again in there already, but I'm not going to touch it. I'm waiting for the year if I could, ride that out, and contribute a little of my own to it as well. And really can't thank everybody enough for that and what they've done so far. And of course, if you could spare anything to help us, get out there again, I want to bring you all with me. I think that's the best part about it is sharing that experience. So thank you for that. Nathan's working on the coils that he's got going on that are going to be up for sale. And I think that should be really exciting for people too, because it'll give people that watch the things that we do here, an opportunity just to open up a box, follow some simple directions, use their best judgment and common sense, and plug and play, Well,
I think the first thing we need to do just to start out, I think it's kind of hard because circuits are bad for people. Let me just say it that way. Leave them on their kids. You know what I mean? Things around there. You got to be an adult in the room. We'll just start out with this, guys. It should be pretty simple for me to be able to take my time and put it into there. And it should be good for you to make a very fast head start. This coil right here, just as you see it, with the 2 wires connecting, you got 2 male connections right here. You just plug them in. You're good to go, man. You want to put a top on it, you know what I mean? A breakout to it, anything else, you're good to go, okay? You get all of it put together just like this is how it'll arrive, okay? We talked about it, and we decided $200 is going to be where the price is at. If you want it, it's there. I'll put it up on Facebook Marketplace. Anybody that's a member, please advise me that you're a member, and I'll give you a discount on the coil. You know what I mean? I think that's the way to go. So, and then when we get into it a little bit more, and I have some way to ensure myself that on who I'm selling it to, and I don't know how that's going to work, because I worry that somebody's going to do that, burn down their house, not knowing what they're playing with. They just bought something online, because this is dangerous. You know what I mean? When you put it under the wrong conditions. So, yeah, I mean, that's where we're at. Then we can figure out circuits and everything else, or maybe they be sold separately. Maybe that's the option there. Like Joe said, maybe a package separately, we do that. But that's where we're at. $200 the coil, man. It's yours. You can rip this thing, man, with spark gap. You can use Slayer exciters, and you can move it with a ZVS, and everything else will work. So
yeah, we'll make sure that there's a proper tutorial out there too for its use, and make sure that you have the right circuit to run it and everything. And I'll continue to talk with Nathan to try to figure a way to get a fully functional system sort of thing out there, because like I know and I've said this 1,000 times, because it's super important. Who gets the credit for these things, or who gets to whatever? The answer is whoever could put it out there where somebody can open a box and use it when it's a product. You really can't rely on everybody out there just wanting to have to get themselves knee deep in understanding and shoulder deep in building things in order just to have something to experiment with and have a greater understanding. That's what we would love to eventually offer, but it's going to take a little bit of time to get there.
Well, like, I'll be very honest with you, man. If you want me to build you a circuit, get you a power source, match it all up for you, okay, with the coil, I can do that. But every one of them is going to be different. Do you want an NPN? Do you want a PNP transistor? Did you want a ZVS on there? Did you want a spark gap on there? I mean, which way do you want to go? Do you want to go a high voltage DC spark gap? I mean, there's so many different ways to do it. And to be honest with you, man, I don't mind building out a kit. The thing is, I just want to be able to make sure people can do this, you know what I mean? And not have to worry about, hey, do I have to wind the coil? Do I have to get a 3D printer to print out the STL file to build the plastics? You know what I mean? Do I have to source where all this stuff comes from? No. I have an account with Amazon that I basically give you the link to every single thing that you need as parts. That I will put a list together when we do the video for the sale of this thing. I'll put that full list together of all the different options. The problem is people want to run AC through it. Well, you got to build the cord, number one. Number two, you got to buy a variac. And then you got to run a ZVS if you're going to do that. You know what I mean? There's just so many different levels. And then if I try to tell you how to put something in resonance and you don't know how, it may take a while. It's not exactly out of the box. If I gave you a Slayer exciter circuit with it and told you, hey, here's a 12-volt plug-in, not a problem. Right out of the box, you can plug it in and start right up. You know what I mean? You can go do one wire energy.
So also, and I want to get with Nathan. I'm not making any promises because we haven't solidified anything yet, but I'll get with Nathan either this weekend or early next week and maybe work on some t-shirt designs, so there's something attainable for everybody. I want one. I want one at this point. And I had a couple cool designs in mind that I was going to talk to Nathan about. So we'll see what we can do about that as well.
Yeah, definitely working on the t-shirt. I found a way to get them printed on demand. So that's definitely an option for us no matter what.
It's awesome.
So, by the way, I have a new STL out on my coil. If you wanted to print it off yourself, you're welcome to. Those will always be free on Thingiverse. But I did put the Old Man Build logo on it. So let me see if I can't pull that up while we talk here. That's kind of cool looking. Here we go.
While you're doing that, by the way, Terrence Howard would make an awesome guest on this show, but he's way too big to want to bother with us. Plus, he got he got razzed out of existence after his couple of Joe Rogan appearances. So that's rough. People weren't ready to hear it yet, and he was coming talking without any receipts, which is never a good look. With complex geometries that nobody understands except for those who know. So, that was on him. He broke a hermetic principle. The lips are sealed, but for the ears of understanding.
Yeah. Anyway, back to this. Here it is right here, guys. Here's the bottom right here. It says Old Man Builds on it. Like I said, it's on Thingiverse. You can download it. I also changed the amount of fins that are on it. Instead of, what was it, 6 on there before, I put 4. Way easier to wind. I did it in like a minute or two while watching, YouTube. So, and as you can tell, look, it came out real clean, man. It just got the 4. Give you plenty of room to adjust it. But I
Hey,
agree with you,
listen,
Joe.
to my eye, that thing doesn't need to do anything but sit somewhere in your house and be worth every penny. It's a pleasure to look at. It's absolutely beautiful. The black and copper totally pops. Really, really
Oh, yeah.
nice, clean work, man. It's good stuff. Anybody should be proud to have that.
By the way, when you run AC through it, man, it makes a monster sound because of the pipe. So here, like, let me just throw this up for you here.
Yeah, and then when you're done with that, show that the spiral breakout.
Oh, I will. So I'll show the AC first.
All right.
I had this thing humming the other day with the red coil in it. Let's see.
Oh yeah.
You see, it starts out really loud. And, oh, it's loud. All right. Oh, sorry, my ears can't stand any more of that.
That was really cool, though.
Let me go back. Let me just show you from the side, and then I'll show you the swirls. The swirls steal the show. You know what I mean?
Yeah, man. Like I saw that, I was like, "Ooh, things need to like be put inside of there." Just it looks like a portal.
They'll put the wrong thing in there, though.
Man,
You
listen,
won't be
that's your own
happy.
risk. Ooh, that baby cooking.
Oh yeah, that's wild, man. It sounds. Let me just hit mute on this thing. When you're in there, it sounds throaty like a muffler because of the pipe. It doesn't quite come out here because you hear the discharge so much. But as I'm sitting in there, whoa.
It's acting like a header. It's got that Detroit gurgle to it.
Dude, I'd be proud to have that coming out of my pipes, dude. That'd be awesome.
Yeah, I think Dodge tried that with the Fratzog exhaust system on the Daytona Charger, and people razzed them for it.
Oh man. Yeah, you can see, by the way, look at this. There's breaks, Joe, in the voltage coming out. Can you see that little one up on the upper right?
Hold on, let me see. Oh yeah, look at that. Yeah, that's free,
And then
man.
look at the one right next to it. Go down to the bottom. It breaks right there.
Yes, yes, it does. So that raises the question: is that an Evo? I mean, I think it is an Evo, regardless. But is it an Evo from the discharge, or is it an environmental Evo like we had talked about, where these plasmatic discharges need to choose where they're going to hit, right? And we know what makes these kinds of currents flow in the first place, right? Like if you run a regular circuit and nothing's hooked up to it, you know, like there's nothing there. So is it pulling from the environment at that point the same as lightning does? And I think that's a question that we posed before, but we were really unable to answer because we just don't have the proper equipment to, take super high speed videos of this stuff.
Well, I took this with my camera, so it works at night. Okay. So this would be fine. I can slow it down. I could put it, you know what I mean, in higher speed.
Right.
So
Well, my point is that even what a high-end camera it would capture, like a really, really high-end camera, right, would capture at a regular type of frame rate, okay, is not going to show every element of these plasmatic discharges because of how fast they work. So realistically, there has to be like professional high speed and or like scientific equipment in order to, be able to fully realize what's happening because any still frame is missing something.
look at that. It's
That's
seriously
amazing, by the way. That's so cool.
it's everywhere in this thing. I didn't even realize it until now, but you could see the discharges as we go. They're broken. I didn't think they would be.
Yep, look at that.
Totally broken.
So is that a residual charge, or is that what we're saying, where it's just yet to hit, just pulling from there and about to strike? Well, the answer is right there, because that when you just clicked over that much, that grew. And that was a forward motion. So it was at the top before it was at the bottom. So it is pulling.
Let's see. Hold on.
You had it a second ago. It was smaller. Then you click forward and it was bigger. And yeah, look, that one's disconnected. Now it's connected. See? Disconnected. Well, that's too far forward, but it's connected. Same placement.
That's kind of hard.
Disconnected. Move forward.
Okay, hold on.
Connected. Then you have that one like that right there on the right. If you click ever so forward on that, there should be one. Nope. This is why the high-speed camera is critical.
Yeah, we're missing the speed altogether.
It's happening. It's capturing something, but it's happening too fast.
Yes, way too fast. Dude, these are like half and half, little tendrils in them, and like total bunch of white. That, in talking to Sean today, it was more about the compression of the coil than it was the rod, going down too far. His coils are compressing at a massive rate compared to this. This is a 4-inch pipe, and you know what I mean? The compression in it's not that much compared to what he's getting. He's getting layer after layer after layer of compression. So
yeah.
that's just.
Yanni says color says a lot. Also just like lightning. Yeah, I mean Bob Grenier brought that up the other day and mentioned that the purple plasmatic discharge in atmosphere is going to be it's a nitrogen reaction. We run on 78% nitrogen in our atmosphere, give or take. So it starts to make a lot of sense real fast.
So electric unicorn horn. I like that. All right, Joe, you ready?
Yep. Let's see the warp hole.
It's the wrong button. There we go. That one. That's the one you wanted.
That's the one. Can you make that bigger?
Like that, or hold on. Nope, that's the wrong one. Here we go. We don't even have it now.
It's gone. Where'd it go? The magic.
There you go. Give me a second. There, that's about as big as I can get it, Joe.
All right. And I'm assuming that band that we see rotating around is the frame rate issue. That wasn't, you couldn't see that with your naked eye, right?
That band, I can see all of it. Matter of fact,
no, that black band that's traveling around. Did that only pick up on the camera, or did you see that with your naked eye too?
No, that's the frame rate.
Yeah, that's what I'm saying.
But there was an orange discharge at the end too. Not that light bulb in the back.
I was gonna say, man, what's that?
Yeah, we got orbs.
Yeah, orbs. Right. There's the orb.
No,
a little smoke and mirrors.
Yeah. Oh, I'm not. No. That's the wire itself, yeah.
Yeah, the band is the wire, but I just wanted to know if it was a frame rate thing as to why it was visual.
That's wild looking, man. It's mesmerizing. Look at that, though. It's like a tornado.
You sell these things at the 4th of July.
Let's see if we can't stop it and look at the plasma in it. Because it's a different plasma on the end, too.
Okay.
Well, because we're normally looking at it through the tendrils, right?
Yeah.
But this
Now,
has
is there
a
a
nice...
theoretical limit to how long that breakout wire could be?
No, I can make it longer.
Because
well, I mean,
I'll
I'm
tell you
sure
what,
there will be.
if you took a stiff, like spring type steel, like something that'll hold its rigidity, you could get that thing friggin' cooking like if it was longer. You know what I mean? If it could just hold its shape.
So you want to do like a spring with it? The vortex is a spring, like a solid one?
Well, that would be interesting, but that's not what I was saying. But that would be awesome. I was talking about like spring steel, though. If you were to get like a piece of spring steel that's like rigid, so it's like flexible and whatnot, but you could stand it upright. Then once it gets spinning and whatnot, it would like if it's the longer it is, the bigger that beer's going to be.
Well, it spins because there's no weight on it, and the ion wind's forcing it in circles.
Right. Well, that's why I asked if there was a limit to the effect.
The weight. Yeah, the weight.
Well, right, but I mean, if it's spring steel and it's inclined to stay propped up and also spin around, it only takes a very small resonant bottom movement to make a large movement at the top.
I don't know that it would work that way, Joe, but I would definitely try it if I had it.
Yeah, that or spring, like you said too. Maybe that's a thing.
I'd be interested to see where the breakout is as it flows up. You know what I mean? And then hits the discharge point. Yeah,
take care, Pete. Thanks for coming, man.
He says the frequency charges encircle into other shapes as well. That'd be interesting to see which frequencies would do different shapes. Oh, yeah, we got to try that. By the way,
you could get standing waveforms out of that too. Technically, what you're looking at is a bit of a standing waveform. It's just instead of it being two-dimensional, it's being increased by the length of the wire. And it's just spiralitic.
So check it out, just so everybody knows. This coil, the one I showed you right here, this is what's making that both types of plasma. It's making the discharge out of the top. It's also making the swirls out of the wire here. So just so you guys know, when you buy one of these, it's been tested. I don't leave anything that's not. You know what I mean? It's got to work before it leaves. So I know that it works for you in case there's a missed wire or something like that didn't solder well or something like that. These things are mean, man. If you know how to work them, you get a whole lot of stuff. You can just buy like a number 2 coil with a cheap platform, which I'll offer as well, and you can light it up from across the room in DC. So if you wanted to go, say 5-6 feet, right? Take another coil and light up a light bulb from across your table with it. You could do it wirelessly and check the tests that I do. So I'll offer that as an option, a cheaper option for people if they just want the number 2 winding and want to pay for just like a little small plastic piece to hold it. There's no problem there, man. We can work that out. You know what I mean? And you could do whatever you want. Build your own primary for it. Like we saw that one primary. Remember when he turned it and then it sparked off? He was adjusting it based on. You didn't see it, did you?
Nope.
Oh, Stay Thing has it, dude. I'm sorry if I said the name wrong. Give me a second. I'll pull it up.
You knew I didn't see, so I was literally staring at
I saw it on your face.
I was like, I don't know. I'm just listening at this point.
Oh, dude, you're gonna be tripped out then. And it's a beautiful quality built, by the way. So take a look at this thing, Joe. So he has it on its side, right?
Mhm.
Same diameter coil, everything. Built it to specs that I gave out.
This is the coil that I built, and I put it on its side because I wanted to do here what you could call a variable primary, I guess. It's just adjustable. I can rotate this whole primary, and that contact slides and turns with it as I turn it. So it worked out pretty well. I can show you here. You can actually tune it in, in real time. So I'll turn it on here and show you. The volts here a little bit. These are old violet ray devices from about 1920s. Just kind of fun. So let's see here. I'm going to turn this primary.
You see that as he turns that primary coil? On the bottom, it changes the resonance in the coil.
Yep. That makes sense.
As it gets into resonance, you can just watch it.
Mm-hmm.
And I put this little shield on here because it was wanting to arc over.
Well, hold on, let's get to the sparks.
So there it goes. See, it was getting into a little better resonance as I turn the purple back into resonance again. Just a little bit. Crank up the volts.
There he goes. You're getting the same thing I'm getting. So I just wanted to show you that, Joe. That was cool because he's taking the primary, and instead of moving the little piece around to see where it resonates at, he just turned the bottom just slightly in order to bring the coil into resonance.
Mm-hmm.
Totally awesome, man. Kind of like a trick that only people who play with them for a long time would know. If it's not setting right in your STL,
Right. It's just adjustable, up, down, left, right.
You just move this a little bit in your primary. You know what I mean? And play with it just a hair to get it around this piece right here. You're good to go.
Tesla coil equivalent of smacking the side of a television. Don't even try that anymore because it doesn't work.
Yeah, not with these TVs.
No.
I smacked the TV once, man, and it shattered. It was.
Oh no, baby! Yo, you must have been not happy with that television.
No, it was not. Yeah, bad time. Anyway, yeah, dude, I think that stuff is cool, man. When the community gets out there and starts building this stuff, like, I would love for everybody to, roll in and say, dude, I'm a member on the channel, dude, give me a discount, get me this thing to me right away, and then watch them just put the parts in, man. A little bit of soldering here or there. You know what I mean? Did a tiny wire that goes in here. Start putting in monster volts to this. I mean, it is absolutely the best. So
yeah, I think Deadfish said he wants to turn it into a bong. I don't blame him. Listen, once you get it home, it's up to you what you want to do with it. That's it. You want to drill a little hole in the side, and Get with it. Hey, you know,
Do what you got to do, buddy. You could light up your cigarettes with that thing. I don't really care. You know what I mean? I'd love to see the test though.
they have plasma lighters. That is a thing.
No, I know.
Yep.
Just got your own kind, huh? No, but that's really cool, man. So yeah, guys, probably on Monday I'll have a listing for it, and then as people buy them, I'll put up another listing and stuff like that. See the reaction of them, stuff like that. They come with I spray on 3 coats of lacquer just to keep all the windings together and tight and lacquered together. There's not a real thick sheen on this thing. So I haven't been able to pull that off like Sean does all the time with his rotisserie. So I'm not at that stage yet. So in the first couple that come out, man, just be careful. Don't whack them with nothing. But the wires do stick together. That's what that lacquer is for. It sticks it to the wires themselves and also sticks it to the pipe so that it stays. So just so we all
Honestly,
understand.
now that I'm thinking about it, man, you should just make like one without a winding and just have it be a bond. Why not just do that? It's already there.
Make what without a winding?
Print the base. Put a piece of PVC pipe in it. there you go. Old man built Tesla bomb.
A bomb.
Yeah.
Literally
You thought I said with a B? I was talking with a G.
I'm thinking.
Oh no, I'm not trying to have anybody I'm not trying to have law enforcement knock on my door. I live in New York. These things are legal. I could talk about these things. You live in California. Things are legal. You could talk about things. Just saying.
Oh yeah, California. You could build any. Yeah, those are on every corner.
New York, same deal. This is how it is.
Yeah, California's getting their tax revenue that way, probably.
Here, you could literally go to the same place that you buy cigarettes, and you could buy like joints and blunts and concentrates and nugs and the whole 9 yards, and put it right on your debit card. I mean, I don't smoke, but like my buddy does, and it's what he does all the time. Same place I got my vape from. You go there and just buy weed. But it's funny because of the tax situation and how the state tries to do it with the licensing and blah blah blah. All these places, they buy all from totally legitimate like outfits. Like they have legitimate outfits that they buy wholesale from, but because they didn't get licensed with the state, they all have these huge like violation stickers on the door, and every smoke shop in the area has them huge violation stickers that says illicit cannabis sales reported. But they don't stop them or shut them down because it's like, what are you gonna do?
I did a favor for my sister. She's working at a trucking company. The trucking company is between 2 places that sell it, right? On both sides. Let's just say there was an aroma in the air every day that I went to work. So, yeah, it's bad in California. They're stacked up by the block, dude.
Oh, it's the same year, but it's funny. Back in 2004, when I was like in high school, I used to me and my friends used to talk about this stuff all the time because I used to smoke a lot back then. I used to be like, man, this is ridiculous. It's never going to be legal. People get in trouble for it. I had friends that just, sold it to other friends within and like half of them got arrested at one point in time or another, and it's like you see all that and you realize, and then you go, 20 years in the future or less in that case, and all of a sudden it's like you could literally walk into the convenience store and it's like you don't even need to think about it.
Yeah.
It's crazy.
Yeah, it's kind of crazy. Well, whatever, dude. Whatever floats their boat these days, I really don't care. Do what you want to do.
Yeah, right. That's what I say. To each his own.
Yeah. Oh, man, the good old days. I see all the comments, and I can't really put too many of them up there, but they're awesome. You guys are really good, man. Yeah, my brother got kicked out of school for smoking cigarettes, man. And now
wow, that's a rough reason to get kicked out of school.
Yeah, dude, he didn't want to go back. He just said, screw it, I'm not going back, and you can have your diploma and shove it. I'd rather smoke than do that. Guy became a cabinet maker, works with all kinds of fractions and geometry and stuff like that. Smart as heck, right? Yeah, well, that school didn't teach him nothing that he didn't need to know already.
Yeah. Well, it's funny. I mean, things weren't like that by me at all. Like it used to be so bad. We used to literally walk out the school building, like right outside the door, and light up a cigarette right there every single day for the entire time I was there, and nobody would be in trouble. They tried to make us go to the lawn a couple of times, and nobody listened. They didn't do anything about it. But times have changed. Like, try doing that now.
Yeah. Crazy. Gets worse, better, worse. It keeps going back and forth. Yeah, I don't partake in any of that anymore, man. Not that it wouldn't be fun. It's just my health won't allow it.
Yeah. Well, I learned something today, and that's that it's time to go to my friend's storage unit and get my air conditioner because it is 70 friggin' degrees in here, and the fact that I haven't passed out of heat exhaustion yet is insane because that's way warmer than I like it inside. That's for damn sure.
Oh, you'll need it for the rest
no
of the
way.
summer. Yeah, the rest of the summer, man. You're gonna need that sucker.
Oh yeah, it's coming out this weekend. It's happening.
Yeah, you just at the beginning of it there in New York, right? Like it barely started shining, real good here now.
Yeah,
it's usually
yeah, it's starting to get warmer. I mean, it's definitely like 80 degrees today. Not that that's hot or anything, but I mean, it's plenty warm. That's for sure.
Well, see, California is different than other states. It doesn't hit winter time until like January, February. And I know that sounds wrong, but it just doesn't. So I get all screwed up in the seasons. It's supposed to be snowing outside, and I'm still walking outside, and it's sunny, right? But here we go. It starts to go to spring, and there's no spring because it's all dreary weather, and it's all cold, and it's like, man, this place sucks like that. But the most of the time, it's just sunny.
Bro, it's fucking HARP, I'm telling you. We used to have springs, but we don't have no springs no more. Thanks, HARP. Yeah. Like you said last week, man, you can't turn it off.
They ruined it for us, man. They're blaming it on
two modes.
Blaming on global warming and cow farts.
Freeze or cook. That's what you got.
Yeah. They go, man, you got all these people out there, these Democrats, let's put the cork in the butt of the cow. You know what I mean? They're farting too much ozone. And then it's like, man, it's really a government agency messing with our weather and playing with things that they shouldn't be. But no, it's cow farts. That's what they come down to. I mean,
man, they've had problems with something or other, and then they go against their own things depending on like their friggin' mood. There's no rhyme to the reason. It's whatever their agenda is, whatever buck they're trying to make off of that week. Some stupid shit.
Oh, dude, that's a money-making proposition. You go out and give lectures on global warming.
Yeah, for real. You remember that like annoying ass like Swedish girl, with Greta Thunberg or something?
Yeah.
You remember her?
Oh yeah, annoying one.
Like literally, I'd never watched anything and been so repulsed in my entire life. I was like, oh.
Every time they take a picture of her,
disgusting.
It looks like she's, dude. Every time they take a picture of her, it looks like she just smelled shit. So,
right. Everything, like, nothing makes her happy, like, because she's just in a perpetual state of fucking bad mood. Like, yeah, good luck. Good luck. Goddamn red flags all over her, and I don't even like that saying. Like I just say let it ride. This is why I'm a disaster in life. I see all the writing on the wall, and I'm just like, yeah, it's probably fine. But her, she's just like, yo, this is going to be an antisocial disaster area for your entire life, hon. It's rough.
Let me tell you something, man. We all thought Al Gore had lost his mind, okay, when he said he created the internet, right? But here the same guy goes around talking about global warming and becomes like, what, a billionaire right now with all the talks that he does on it? I mean, like, how do we know, man? It's like some things are so stupid that they make the most money ever. Like, I give him credit, man, all day long. This guy became rich, and he made a whole subject about himself, you know what I mean, that now everybody bought into.
Yeah,
So
that's true.
that,
Oh yeah,
that's
then
amazing.
while we're off subject, I want to welcome Albertans to the United States of America. Congratulations on making your moves to cut your ties.
Nice.
Righteous cause, 1776.
Don't know what you're talking about, but okay.
Oh, well, the
I know what
Canadian election was this
1776
week,
is.
right? The Canadian election was this week,
Oh,
and it was supposed to go kind of one way, but there was all sorts of, propaganda campaigns, blah, 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 leading up to it. And the friggin' polls shifted like this, right? And their conservative candidate, who was originally like a front runner, lost. And Alberta, who's been like hit hard by the tariffs and has a lot of the industry and a lot of their exports and everything like this, is like just fed up with the whole situation. And they're like, yo, we're done with you guys. We're done. Like, we want out. We don't want this. So
oh, they're going to
now,
join the United States. Is that what you're saying? That
either independence
out?
of the United States. I think Bernie's from Alberta, if I'm not mistaken. So
Oh,
we might have a new American at some point in the near future. They're trying to say that even if they go that route, it would take years for the secession to be complete, and then if they were to be either independent or join the United States. But it looks like there's wheels turning, so that's interesting.
we've been trying in California to secede from Northern California for a long time. Those people are morons. Like, we just want away from them, and they won't let us.
Listen, I said the same thing about when I was living on Long Island, and now that I'm up here too, same difference. Long Island and upstate New York want nothing to do with the city politically. Just just throw them out, make them their own thing. It doesn't matter. It's okay.
Yeah.
They never let it happen though.
That city lives in clown world. That whole thing. I don't even know what to say about it. Well, we got the same thing in LA, so don't feel bad. So it's all man. Clown world. Then we go up to San Francisco, and we literally have a map where they took their dookie everywhere. Like, if you made a poo on the street, they logged it in. Like, some guy's walking around logging this stuff in his computer. Like, man, that was a good one. You got to log that thing in here. And then there's a map for people to go out and visit them. Like, you can literally visit the poo all the way around. It's like the entertainment. You sit down to have lunch, you get your 2 grapes and your little piece of watermelon slice for your $100, and then you can literally watch a guy drop a deuce right there in front of you.
It's disgusting. And you know something? I'm old enough at this point now to say that I've seen similar things happen with New York City. Because, see, when I was a kid, the city wasn't the cleanest or safest place. Generally speaking, it was kind of dirty. It was pretty run down. There was all sorts of debauchery going on and whatnot. The 80s were a rough time for New York City, and the early 90s. When Giuliani came in, he cleaned that place up. He got that place as close to excellent, given the population size, as you possibly could imagine. And it was like to the point where it was not only safe, but it was also clean. There was infrastructure projects. I mean, it's still Manhattan and the boroughs at the end of the day, but much less of a shit show than it then became in years to follow.
You can actually ride the subway, from what I heard.
Oh yeah, man, it was fine. And yeah, and then I went not too long ago. I was like, this is not enjoyable anymore. Like, it's gross. It's disgusting people everywhere. Poverty just everywhere. Nobody speaks English. It's gross. And all the things that you just said too, to a lesser extent, because I think that's kind of where people in New York draw the line. Like, if you're taking a shit on the sidewalk in New York, someone's gonna give you an attitude real quick, like kick the crap out of you.
Hold on. I've seen people punching old ladies walking down the street in New York. They keep showing it on the news.
This is what I'm saying. Like, New York's tolerance for other human beings is very, very limited. Like, there's not a very live and let live attitude here, So, like, if you're encroaching into somebody else's like zone of existence, like, you're gonna know about it real quick. So like this whole somebody's taking a dump on the sidewalk with a junk needle hanging out of their arm, just walk around them and whatever and ignore it. Like yeah, that would never fly here. So there's probably less of that. But take a whole bunch of illegals and stuff and dump them into a hotel and have them all camped out outside, walk right around that and ignore it, whatever. Yeah, it's a whole other thing, man.
Wow.
Mm.
Yeah, big cities, man, big problems, I guess.
And one other cool thing that I recently discovered, and I guess it's been around for a while, but it just shows kind of like the direction of everything going, and states themselves taking a little bit more of an independent approach to the environment at hand. They're issuing now these gold-backed currencies in like 6 different states. So there's like a premium over spot, and it's pretty big, but they also have inherent value. So what these gold-backed currencies are is they take real gold, they press them out into a semi-foil. So it's not like gold leaf where it's like nothing, right? It's actual with weight foil of actual 24 karat gold. They laminate them in polymers and print them with all sorts of security features all over them, and then sell them out of kind of banks, so to speak. And they're labeled for a state, and they're not legal tender, but they kind of are at the same time. There's like stores that accept them and everything, and they have their own trade values. And the way that they work it is their denominations are a point of like spot of gold. So it depends. So their values fluctuate every single day. And you could use them as you would, or you could literally just stash them, like collect and stash
this
them.
is legal in each state?
In 6 states, it's tender. It's just not it's not legal United States tender, but it's legal state tender. And not every store has to take it. That's sort of where it's at right now. There's a couple of states, I feel like maybe Utah and Florida or something like that. There's a couple of states that are trying to pass it to where like that it would be legal tender in the state that one where they actually have to accept it.
Wow.
But some of them are crazy. Like one's 1/1000th of an ounce of gold, 1/100th, I think a 50 denomination, which is I don't know what the amount dollar wise trade would be today, but it's like 1/20th of an ounce of gold is like their 50 denomination. So if you have 20 of those bills, that's actually 1 ounce of gold. It's like almost $3,000.
That sounds crazy, Joe. That's kind of crazy.
Well, it gives people this alternative currency that they could use, but also it's literally gold back, right?
Yeah, well, literally,
it's gold in your hand. It has all the value of gold. It's just a usable form.
It's crazy, dude. I watch those gold mining shows. That Gold Rush, man. Love that show. I'm not so into the water ones, but the ones on land, you know what I mean? When they get out there and they dig through all this dirt to get all that gold. And I'm thinking, man, can't you eventually make an electromagnet and pull the easy stuff off the top? I mean, that would be super hard, but it'd be super helpful if you could do it.
You can pull the gold out of anything, man, but it's just like process. It's a lot of work to do it. Gold is everywhere, but it's not that it's rare. It's just difficult to extract. That's what it boils down to. I went down panning by the river by me, just one pan. Got a couple of flakes. I mean, it's not worth anything. They'd have to pan and pan and pan and pan, or have like a sluice or something and just go at it all day long to have any sort of dollar values worth of gold, but it's everywhere.
Yeah, good luck, man. Then you just think make you give it back.
Yes. Which is why, I mean, it's only for fun. Because there's nothing to gain out of it.
It's like fishing. You just put the fish back when you're done.
Hey,
After you ripped out half of his face.
You're right.
Fish.
You sit there, you gill hook the thing, and you're just like, like he doesn't have a fighting chance in hell. Throw him back.
Oh, yeah.
Meanwhile, they're the ones that stock them in the first place. They're not even like native breeding populations. So you be throwing this thing back that's gonna die anyway that didn't even exist in there before you put them there. Like, come on.
Oh. See, my state's so bad at that. They're trying to make a river back to LA. And they say, oh man, it's about putting fish back to their habitat. Well, I got news for you, buddy. Once you change their habitat, it's game over. They can't follow the same trails to it. So they'll never go back to it. You're taking a new population, putting it in a new area, and you're doing it so you can put more cement down so people can sit in more little lawn chairs while they eat their food and watch the river go by. And then hate the smell
and all the runoff from like the 12-lane highways and all that stuff. Like, come on.
Oh yeah. They're trying to, what do they call that phrase? Shine a turd. That's what they're doing. That's literally what they're doing.
Pretty much. Tell you what they won't do is make a gradient differential for that to actually use hydro powered electricity off of it, because why would you want to make clean energy in a state where they where they make you drive like electric cars and penalize you for every single fart that you have or every single sip of gas
Are you kidding me? They stop the water so that they can have fish over there.
Yeah.
California's so backwards, bro. It's just backwards. It's like we elected some of the dumbest people, and since we keep voting one party only, we keep electing the dumbest people. So the scale of dumbness continues to rise as we elect them, and it just keeps going up slowly until the guy can't even speak English in the end is what's going to happen. Like,
well,
we'll never understand
that already happened, bro. Like, Arnold Schwarzenegger was your governor one time. You know what I mean? Like, I'm pretty sure that after you elect the fucking Terminator, as your governor and stuff, you just lost all opinion on anybody else's elected officials. And I'm not saying Arnold's a bad guy, but I'm just saying, like, it's ridiculous. Anyway,
oh man, I guess that is really bad when you look at that.
Right. And if it's all been downhill since the Joppa, like, I mean,
dude, hey, it was an upgrade versus the other party that was in there, man. It was bad. You know what I mean?
I hear you.
I mean, we what did we do? We elected a governor, kicked him out of office and elected somebody else, and then we re-elected that guy again because there was no one else to run. So he got another 4 years of, oh my God, this is horrifying. We know why we got rid of you the first time.
Well, listen, this is exactly what Canada just did. They literally, their prime minister was so bad that they're like, you ruined our country. All right, we'll hold an election. Just run one of your friends and we'll elect him. Somebody that's been there all along that's just as bad, and we'll elect it. Like, do people have a brain? You know what I mean? Like, even if it's not outside the party, can it at least be somebody that wasn't directly involved in the first disaster? Like, maybe give somebody else a try. I don't know.
We just had a presidential election that just went through that. Someone was involved in the last, person's whole setup, man, and then they ran them. Like, what did you think was going to happen?
I was there for it, brother.
So bad, dude. I guess we just don't learn. Like, for as smart as we get, and we talk about physics, we talk about, science stuff, then we go to politics and we just all lose our brain. Like, what the heck happened there? And like, people are crazy about that stuff too, man. Like, you can get along with your buddy having beers, and then you bring up that kind of stuff, and they're crazy. It's like, dude, you need to go home. Like, that's bad.
Yeah, I let everybody have their beliefs, and I have mine, and that's sort of it. But I think that it's fair across the board that when you see something that's absolutely absurd, that you just call it out for what it is, because it's because it's absurd, and that's absurd. You have a guy that destroys your state, you have a guy that destroys your country, and then the answer is, well, who was second in charge overseeing this? Let's get them in. Stop.
Dude, it's like the backup quarterback that comes in and wins one game, and you're like, well, it was better than the starter, so let's have him play next year. And you always regret the decision, because the next year you just all the way across the board, and you're like, oh, that was pretty bad. Maybe we should have got somebody else. Oh.
Yeah. Well, it's been awesome day in the chat today. It's been very quiet. We haven't had any green tall-haired people out in the chat today that I've had to, shut up or nothing like that, which I really do not like doing. That's against my entire like mantra here of like live and let live, and yeah, people say stupid stuff and whatnot. But yeah, so thank everybody for that. All cool people today.
Right on, man. Yeah, I just that guy, man. Every time.
Honestly, it's so unimportant to me that I don't even remember his name, but fuck that guy, honestly. Piece of shit. It's all peace and love until you piss me off. I mean, that guy aggravated me. I'm just saying.
He's probably still watching.
Oh,
he just didn't say anything today.
Well, you better not, or else he'll never say anything ever again. Pull out the hammer.
No. That's so funny. We'll just have Brandon talk to him. Brandon, cheer him up.
That's it. Brandon, start Putin up and be like, start chasing him 3 miles an hour. Anyway, digress.
All right, guys, I want to thank everybody in the chat for hanging out with me. And Joe, guys, awesome show, man. We actually covered 2 topics today instead of 1. So, like, total mind blower, man. Because we did 1 hour and 1 hour and another, man. It turned out really awesome. So, hey, don't forget to help out Joe and going mining. So I'm going to go ahead and pull that up again real quick because I want to put it in the chat. Also, guys, I put it in the description of the video so that everybody can check that out and that they can click on the link. I'm sorry, it took me a minute. I'm trying to do 2 things at once. You tell I can't. There you go, right there. Help Joe go mining.
And again, thank you very much to anybody who's already contributed. And actually, for what it's worth, I was thinking that I might, and I'll get with you over the weekend, but I might go either tomorrow or Sunday to a lesser place, like place that's like much less expensive, way more low key, whatever, but still the same sort of deal where like breaking rocks, seeing if I can find some like double terminated quartz, whatever. Just keep me going and keep the whole idea of it, the interest in it going, until I can get back to the other place. But I actually shared a video with Nathan. We don't have to play it or nothing, but they were out there digging today and they found the double terminated piece the size of my hand. So nice. Yeah, it was a pretty big piece, like pretty impressive. So those things are out there, and I need to get back there. And I really appreciate everything everyone's done. So
right on, guys. Thank you very much. Have yourself a great day, Joe. Thank you.
All right, peace and love, everybody.
The old man will. The old man will. The old man will. The old man will. The old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. 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 wheels of destiny are spinning in his mind, making him travel back and forth in time. Battling the establishment for just a little recognition has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds